Hi guys! Welcome ulit sa YouTube channel natin. Now today, meron tayong bagong topic. We have the deflection of beams by moment area method. Okay? So anyway, this is just a continuation sa topic natin sa deflection of beams. Last time tapos na tayo sa double integration method. Now ngayon, we have the moment area method and then yung next nito, actually conjugate beam method. Now, unahin muna natin itong moment area method. Anyway, mas madali na lang maintindihan yung conjugate beam pag alam nyo na yung moment area method. Okay? So, same pa din guys, as I try to create the video, I'll be addressing my students, okay, sa theory of structures na klase namin. So, yun nga, feel free to use my lecture video materials, and of course, I hope na nakatulong din ako sa mga nagtitake ng online classes sa theory of structures. So, marami din pa salamat sa mga nag-subscribe at saka sa mga hindi pa nakasubscribe. So, please subscribe na lang din para makatulong kayo sa channel ko. And of course, para din ma-notify kayo kung meron pang mga bagong videos tungkol sa subject na to at saka mga ibang subjects sa CE. Sorry. So, anyway, yeah. So, sa video na to, meron tayong concepts, meron tayong mga formulas, mga equation, and of course, yung pinakagusto niyo, meron tayong mga example problems. Okay? So, yun nga. I think yan lang ata. So, let's start. Okay guys, so anyway, from the name itself, no, moment area method. So, in this method guys, we will actually use yung mga moment diagrams sa beams ninyo. So, it is important na alam niyo kung paano gumawa ng moment diagram. So, I hope naalala nyo pa from your strength of materials yung paano gumawa ng shear and moment diagrams. So, for example, meron tayo nito. Simply supported beam, ganon. Yan, simply supported beam. Tapos meron siyang uniformly distributed load. Okay, again, sorry kung medyo pangit yung drawings natin. Yan. Meron siyang uniformly distributed load. So, yung shear natin, yung shear diagram, di ba? Upward due to the concentrated load, and then bababa, linear. Tapos tataas ulit. Okay? So, anyway, yung moment diagram natin is ganun. So, it will increase. Starts at 0 kasi wala namang moment sa free end. Starts at 0, sa edges, diba? So, starts at 0 and then it will increase. Okay, maximum dito and then bababa ulit dito. So, we are just interested dito, guys. Yan. Okay? Pag alam mo kung paano gawin yan, yung moment diagram na yan, so you can actually use this method. Okay, so prerequisite na alam mo dapat kung paano gumawa ng moment diagrams. So anyway, later on, you will actually encounter mga moment diagrams na medyo mahirap. Okay, mahirap kasi moment area method, diba? So we need the areas of these diagrams. Now ito, parabolic, walang problema, alam niyo yung area niyan. Okay? What if medyo pangit na yung mga areas na, pangit na yung moment diagrams natin? Okay, so medyo mahirap na tayo i-solve yung mga areas ng moment diagram. So, don't worry guys, meron tayong mga techniques na gagamitin to avoid yung mga complicated na mga moment diagrams. Okay? As much as possible, dapat madali lang yung mga moment diagrams natin para madali lang din yung pag-solve natin. Kasi, nakabase kasi lahat ng mga solutions natin sa moment diagrams natin. Okay? So, anyway, balik tayo dito. Yan. So, before tayo sa mga example problems, no, sa mga formulas, we need to memorize itong dalawang theorems. Yung moment area theorems na to. Now, itong theorems na to, ito yung gagamitin natin to solve for the slopes and deflections sa beam. Usually kasi yung tinatanong sa problem, hindi lang naman deflection, diba? Find the deflection at point A, point C, ganon. Kailangan din natin, usually, tinatanong din sa problem, find the slope at point A, find the slope at point C. Okay? So, yung first theorem natin, yan yung first theorem natin. Itong first theorem natin, guys, magagamit natin to solve for the slope at a certain point. Okay? So, check muna natin yung theorem 1 natin. Okay? So, the change in slope daw between any two points on the elastic curve, between any two points on the elastic curve is equal to the area of the M over EI diagram between these 2 points. So, anong ibig sabihin nito? So, for example, balik tayo dito sa beam natin kanina. Yan. Sandali. Balik tayo dito. So, yung elastic curve dito, guys, is pag ganito, no? Yan. For example, ganito na lang yung elastic curve. Yan, okay? And then, di ba sinabi sa theorem na the change in slope daw between 2 points. So, we need to select 2 points, okay? For example, ito yan, point A. Yan, point A. And then, we have point B. Okay? Now, to solve for the change in slope, i-draw muna natin yung tangents nila to solve for the slopes, diba? So, this will be the tangent at A. Yan. Okay, tangent sa A, di ba? Kaso nga lang, hindi ata tangent sa drawing ko. Anyway, intindihin nyo lang yung drawing. Tapos, we have the tangent at B. Yan, okay? So, the change in slope, di ba? Kung slopes na ang tinatanong, to solve for the slope at A, we just need to solve, ito, di ba? Kailangan lang natin to. Ito. Ito yung slope sa A, di ba? Yan. So, likewise, same din. To solve for the slope at B, ito yung slope sa B, ganyan. So, we are not interested sa slopes. Rather, no, we are interested sa change in slope. So, ang change daw in slope, so from the figure, ito ata yun, di ba? Yan. Okay? Yan. So, the change in slope or the angle between the two tangents is actually equal to the area of the moment diagram between those 2 points. So, balik tayo dito sa moment diagram mo. So, project natin dito. Yan, project din tayo dito. Okay, so meaning, okay, yung angle na to, okay, masosolve natin yan just by solving the area dito sa baba. Yan. I-solve lang natin dito. Area dito. Okay? Yan. Okay, so i-solve lang natin ang area dyan, then you can easily solve for the change in slope, ha? Hindi yung exact slope sa A or exact slope sa B. Change in slope. Now, sir, paano yan, sir? I am not interested sa change in slope. Ang gusto ko, sir, is yung slope talaga. Now, don't worry, guys, meron tayong mga example problems mamaya. Makikita nyo na itong theorem na to, ito yung gagamitin natin. For example, to solve for the, halimbawa, slope sa A. Okay, so kung isosolve natin ang slope sa A, yan yung gagamitin natin na theorem. Okay? But, yun nga, diskarte na natin kung ano yung change of slope na isosolve natin. Okay? To solve for the slope at A. Anyway, later on, meron tayong mga example problems. Okay? So, I hope naintindihan nyo yung first theorem. Simple lang. Okay? So, sa figure natin, tingnan nyo, halimbawa, ito yung elastic curve, and then we have point A and point B. Okay? So, ito yung tangent sa A, ito yung tangent sa B. So, ito yung theta sa tapos AB. This is actually the change in slope. So, ang value nito is simply equal to the area of the moment diagram. So, area of AB divided by EI. Ganun lang. Area from A to B. Now, to solve for the area, ikaw nang bahala dyan. Okay? So, yung area natin, for example, yung diagram mo is rectangular. So, base times height. Kung triangular, 1/2 base times height. Ganon. Okay? So, yan. Area lang. Now, sir, ano tong mga ibang, mga variables na nandito? So, actually, kailangan natin to sa second theorem. So, anyway, explain ko na lang. Ang tawag natin dito, guys, dito sa T, B over A, this is actually the deviation. Okay? So, deviation of the tangent, deviation of the tangent, no? Yan, deviation of the tangent. Now, ang deviation natin, guys, by the way, ang deviation is the distance or vertical distance between the tangent and the elastic curve. Importante yan, ha, tangent and elastic curve, ha, hindi tangent and tangent, tangent and elastic curve. So for example dito, okay, so dito, this is actually ito, this is actually the deviation of B, okay, deviation of B with respect to the tangent at A. So ito yung distance na yan. Okay, ito. From here, ito yung vertical distance. Yan. That is actually our deviation. Likewise, meron tayong tangent at B, no? So, ito yung deviation sa A. Tingnan nyo. Ito yung length. Yan. So, this is actually the deviation at A with respect to the tangent at B. Okay, kasi sa tangent at B kasi tayo nag-measure yan. Okay, so ito yon ang deviation. Anyway, papakita ko na lang. Meron tayong figure mamaya. So, sa next theorem natin, guys, maliban sa area, we actually need the centroids of the area. Ito na yung medyo mahirap, yung theorem number 2. Yung theorem number 2, ito yung gagamitin natin to solve for the deflections. Ang theorem number 1, walang problema. We will just deal with areas. Now, theorem number 2, check natin. Yan o. So, sa second theorem, guys, sinabi dito na the vertical deviation daw of the tangent at point A, di ba? Ito yung point A. Okay, tapos ito yung tangent at point A. The vertical deviation of the tangent at point A on the elastic curve with respect to the tangent extended from another point. Okay, ito yung point, di ba? Okay, another point. This is actually point B. With respect to the tangent extended from another point B is equal daw to the moment of the area under the M over EI diagram. Now, malito kayo. Tingnan nyo. Moment of the area. Anong ibig sabihin nito? Now, naalala nyo, para bang nirotate lang natin yung moment. Diba? Naalala, ano yung moment? Moment is simply equal to the force times distance, diba? Perpendicular distance. Now, naalala nyo sa Varenius theorem natin, diba? halimbawa, composite areas. Okay? To solve for the centroid sa composite areas. Naalala nyo pa? Okay, di ba? Ang gagamitin natin, guys, we will actually solve for sa area and then i-multiply natin sa distance, okay, sa reference point to the centroid of the area. So, dito na papasok. Tignan nyo, itong x sub A at saka itong x sub B, this is location to ng centroid with respect to A at saka with respect din to B. Now, dito guys, tingnan nyo dito sa formula natin. Yan, So, ang value daw nito, for example, this is the tangent of B. Okay, with respect, deviation, by the way, T is actually deviation. Deviation of B with respect to tangent at A. So, ang value nito is actually just equal to the area from A to B and then multiplied by, since we're interested sa deviation sa B, i-multiply natin to sa centroid of the area with respect to B din. Kasi tangent sa B man yung hinahanap natin. Ganun lang. So, meron lang siyang nadagdag na centroid. Okay, so wag niyo kalimutan na ang centroid, depende yan kung ano yung deviation na hinahanap mo. Kung ang deviation na hinahanap mo is the deviation of point B, okay, dito sa point B, meaning yung centroid, okay, yung centroidal distance must be from point B din. Okay? So, likewise, tingnan nyo dito, TAB, tingnan nyo ito, TAB or the deviation dito sa A with respect to tangent at B. Okay? So, to solve for this distance, ito yung ang length na to, from here, from A to this tangent B, kunin mo lang yung area from A to B and then multiply that area, okay, by the distance, no, sa centroid ng area to A. Ayan, multiply natin sa XA. Okay, now sir, paano natin masosolve yung, wala siyang sinabi na deflection dito, di ba? Deviation, yung theorem number 2 deals with deviation. Walang deflection na term, di ba, na ginamit sa theorem to. So, paano natin gagamitin tong theorem na to solve for the deflection? Okay? So, anyway, I think ang pinakamagandang paraan, guys, to show you kung paano natin gagamitin yung theorem 1 para sa slope at saka yung theorem 2 para sa deflection is by, of course, solving problems. Ito yung mas maganda kasi pag meron tayong problems, makikita nyo kasi kung paano natin i-apply yung mga theorems na to in solving for the deflections and slopes. Okay? So, let's try to solve some example problems. And then later on, kung meron tayong mga mahihirapan na mga concepts, I'll try to explain while solving the problems. Okay? So, check na natin yung mga sample problems natin. So, ito yung first problem natin, guys. Yan. So, determine the slopes at point B and C of the beam. So, since we are interested sa slopes, ang gagamitin natin dito is yung first theorem, yung theorem 1. Ano yun? The change in slope between 2 points is simply equal to the area of the moment diagrams between the 2 points. Okay? So, check natin. We have a cantilever beam. By the way, fixed to sa A. Cantilever beam to, we have yung point B is actually 15 feet away from A. And then yung C natin is 30 feet away from A. So, bali 30 feet yung length ng beam natin. So, E, this is actually the modulus of elasticity, 29 times 10 to the 3 KSI. And ang I naman natin is 600 inch to the power 4. So, anyway, let's try to solve. So, again, ano yung prerequisite, diba? You need to draw muna yung moment diagram nito. So, to draw that, depende na niya, diskarte na nyo kung paano nyo gagawin yung moment diagrams. Anyway, after solving the problems, papakita ko sa inyo yung mga shortcuts kung paano tayo makagagawa ng mga moment diagrams. Okay? So, transfer ko muna to dito. So, bali ganito yung beam natin, no? Yan. And then, we have 2 kips dito. Okay, and then, 15 feet para sa dito. And then, another 15 feet para dito. Okay? So, to draw the moment diagrams, siguro mag-draw muna ako ng shear diagram and then moment diagram para hindi kayo malito. Okay? So, to draw the shear diagram, kailangan ko muna yung reaction. So, anyway, I hope agree kayo na meron tayong reaction dito which is equal to 2 kips din. Okay? And then, dapat meron tayong moment reaction din dito. M, negative moment reaction. Again, negative bending, diba? To counteract the 2 kips. So, ang moment dyan, I think obvious naman, no? I hope obvious para sa inyo na 2 times 30, which is equal to 60. Okay, so, burahin ko muna to. Lagay ko lang dito agad, 60 kip fit, ganun. Yan. Okay, so anyway, I'll try to draw the shear diagram. So, ang shear diagram nito, guys, from the figure, di ba? Nasanayan natin na magsimula tayo sa, Magsimula tayo sa left, no? So, upwards, 2 kips, positive. And then, constant, so straight line lang. And then, downwards, 2 kips. Okay? So, this is actually a positive shear. Positive yung area dyan. Now, yung moment natin is, now, yung moment diagram natin, kung mapapansin nyo, hindi siya This is actually the shear diagram, ha? Yung moment diagram natin, hindi siya magsisimula sa 0. Bakit? Meron na kasi siyang negative 60 kip feet, no? Na bending sa left. So, meaning, by the way, sir, paano mo nasabing negative, positive yung nandyan sa figure mo? Again, hindi dahil walang sign na negative or positive, positive na yung moment. Ha? Again, negative stands for negative bending. Di ba tinuruan ko na kayo kung kailan positive or negative ang bending. Now, hindi yan dahil clockwise or counterclockwise, dahil yan sa itsura ng beam, no? Pag nag-bend, di ba? Pag ganito yung bend, ganyan yung effect, okay, ng moment, that is actually the negative bending. And then pag ganon, di ba, positive bending yung beam natin. Anyway, so since meron tayong negative 60 kip feet, so dapat dito yan magsisimula, no? Pababa dito dapat yan magsimula. Negative 6, pangit yan. Negative 60 kip feet, yan. And then notice na we have a positive area, di ba? Positive shear man yan, positive area. So it will actually increase. Tapos linear yung pag-increase. Kasi 0 degree man to, di ba? So, dapat first degree linear lang yung pag-increase ng moment natin. So, from here, tataas yan. Okay, hanggang dito siguro. Pero, ano yung value ng pagtaas? No? Ang value ng pagtaas is equal to the area from area nito. Ano yung area nito, guys? That is actually 2. Di ba? 2, by the way, this is actually 2 kips. 2 times 30, which is equal to 60 din. Therefore, the change in moment, no, from point A, tawagin natin itong point A dito, to C, this is actually 60. So, negative 60 plus 60, 0. So, meaning, dito yan, mag-e-end, mag-terminate. So, gawin lang natin yan. Yan. So, parang ganito yan na yung moment diagram natin. So, ayo pa, agree kayo sa moment diagram natin. So, moment diagram natin is actually a negative. So, negative yung moment natin. So, yan lang, guys. Now, let's try to check. Tapos na tayo, di ba? Tapos na yung prerequisite. Draw the moment diagram. Now, how can we use the theorem, yung first theorem, to solve for the slope at B? Now, to do this, guys, medyo complicated kasi kailangan natin i-draw yung elastic curves, ganun. Tapos, dapat meron kang maganda yung mga imagination natin dito ba. Tingnan nyo, i-drawing ko, ha? I-draw ko muna. So, halimbawa, ganito. Dito, i-draw ko muna yung beam natin dito. Di ba ito yung beam natin yan? Okay, so, ang assumed elastic curve siguro pag ganito. By the way, naalala nyo, basta fixed, di ba? 0 muna yung slope dito. So, straight muna ito kaunti, tapos dito na mag-deform. Okay, so, i-deform na lang natin. Again, this is just an exage, ha? Deformation, yan. Okay? Now, I am interested sa slope sa B. So, for example, dito, ayan. Ito yung point B, and then, i-draw ko yung tangent sa B. Eps, yan. Yan yung tangent sa B. Now, to get this slope, okay, kailangan ko lang yung rise over run, di ba? Sa point B or sa tangent sa B. So, ito lang. This is actually the slope at B. Uy, sorry. Pangit. Pangit pa din, but lalagay ko na lang. Now, ito yung slope sa B, guys. Yan yung slope sa B. Yan yung gusto ko sanang isolve, but hindi ko alam kung paano. Okay, now, how can I use yung theorem kanina? Now, sinabi sa theorem kanina na ang change of slope daw between 2 points is equal to the area between the area of the diagrams, moment diagram, between those 2 points. Okay? So, paano ba to, guys? So, since meron akong first point, meron akong first tangent, which is yung tangent sa B, kailangan ko ng other point, di ba? So, pag cantilever beam, guys, actually, yung other point nyo, usually talaga yung other point is yung fixed end. Bakit? Kasi alam mo na kasi kung ano yung slope doon. Ano yung ulit yung slope dito sa fixed end? Di ba 0? Therefore, kung 0 ang slope niyan, meaning yung tangent niyan is horizontal. So if this is actually the tangent at A, okay, ito. Mean tangent at B, di ba? Ito yung tangent sa B, yan. Tangent sa B. So ang tangent sa A, guys, ito lang. Di ba? Ito yung tawagin ko tong tangent sa A. Tangent A. Di ba? Diba? Ito yun, no? Tangent sa A kasi horizontal man yan. Diba? Now, ano yung na-notice niyo? Asan dyan yung change, okay? Asan dyan yung change of slope between tangents A and tangent B? Diba ito yun? Diba? Ito yun, no? Itong dalawa na to. Yan. Diba? So, ito na lang yan. Diba? Ito. Now, ano yung masasabi nyo dyan sa angle na yan? That angle, guys, itong change of slope, no? That change of slope from B to A, okay? Or from A to B, that change of slope, that is actually just equal to the slope at B. Diba? Do you agree? So, if you can actually solve this, okay, yung slope sa B, change of slope, okay, from B to A, you can actually solve the slope at B. So, ganun na, diba? Ginamit natin yung theorem, okay, to solve for the slope at B. Even though, yung theorem, hindi siya nagsabi na ito, ang specific slope is ganito, ganyan. Okay? So, ito yung ginagawa natin. Okay? Para bang ina-analyze lang natin. Now, don't worry guys, sir. Unfair sir kasi cantilever man yan, di ba? Madali lang kasi alam mo yung slope na isang point. Yun nga, pag cantilever beam guys, yung isang point mo usually na kino-consider is yung nasa yung fixed end kasi alam mo na horizontal tapos zero yung slope. Now, don't worry guys, next na mga problem, meron tayong mga hindi cantilever beam, tapos yun nga, pakikita ko sa inyo kung paano natin isosolve yung slopes. Now, ito, I hope naintindihan ninyo. Okay na, yung change of slope, no, between B and A is just equal to the slope then sa B from our figure. Okay? So, anyway, to do that, kailangan ko lang guys, yung moment, okay, or yung area from B to A. Ito lang. Balik tayo dito sa figure ko. Ito lang, oh. Di ba? Ito yung B. Nandito yung B, no? Ito yung B, ito yung A. Kailangan ko lang to guys, ito. Okay? I just need to solve for that area. Pag na-solve ko yan, then I can actually solve for the slope. So, check na natin how can we solve for this. Now, di ba trapezoid yan? So, since trapezoid yan, kailangan ko yung area, this is actually 15 feet, no? 15 feet to. So, kailangan ko to guys. Pag na-solve ko itong intensity na to, then I can actually solve the area of the trapezoid. Now, I think walang problema, no? Ratio and proportion lang if this is 15, di ba? So, anyway, negative 60 yung height ng triangle. So, obviously, yung kalahati nito is actually negative 30. So, this is actually negative 30 feet. Okay, so, ano nga ulit yung area ng trapezoid natin? Formula sa area of trapezoid. So, ilagay ka lang dito ha. The change in slope from B to A is actually just equal to the slope at B. Okay, now the slope at B, alam natin, that is actually the area from A to B. Okay, dahil nga sa first theorem. Okay, na ang change of slope from B to A is just equal to the area from B to A din. Okay, so area niyan is 1/2 base times height, diba? Tapos, paano ba to? Okay, so check natin. 1/2, 60, sorry. By the way guys, i-carry nyo na lang din yung sign. Anyway, sa mga students ko, I'm not, doon, okay lang sa akin kung yung sagot nyo ba negative or positive, yung slope, walang problema. Basta same lang tayo ng value. Okay? So, anyway, ano ba to? Negative 60 minus 30 over 2, diba? I-add kasi natin yan. And then multiplied by the base na 15. Okay? So, yan. So, that is... Uy, by the way, nakalimutan ko. I-divide natin sa EI. Anyway, balik na lang. Ay, sorry. So, 1 over EI multiplied by the area, no? From A to B. So, ano yung area natin? Negative 60 plus negative 30 over 2. And then multiplied by 15 feet. Okay? So, yung area natin, that is actually, ano yan, negative 60, so 90, divide by 2, that's 45, no? Tama, 45, and then multiplied by 15. So, negative 675. So, that is actually negative 675 over, negative 675 over EI. So, ito na yung slope natin, guys. So, ano yung unit ng 675? That is actually, yung negative 60, keep feet, no? Keep feet. And then, multiply natin sa feet. So, this is actually keep feet squared. Okay? Keep bit square. Yan. Okay, so anyway, pwede ninyong, kayo na yung bahala. So, hindi ko na lang kukunin ha, yung exact answer talaga. At least, alam na, nakita nyo na ba yung concept. So, again, if you want the exact answer, i-divide nyo lang by EI. So, you have your modulus of elasticity. You have 29 times 10 to the 3 KSI. And then, yung I nyo is 600 inch to the power 4. Okay, as long as same lang yung units. Anyway, sagutan lang natin yung exact value. So, substitute natin yung EI. So, this is negative 675. Keep. Ano nga ulit yung unit? Okay, KSI. So, notice na feet squared yan. So, multiply natin yan. Convert natin. So, yung feet. Okay, so 1 feet. Yan. Sorry. This is actually 12 inch, di ba? So, square lang natin to. Yan. So, makancel out na yung feet. So, inch na lang yan. And then, divide that by EI. Yung E natin sa problem, that's 29. Ano yan? 29 times 10 to the 3. Tama? Kilopounds per square inch. And then, multiply that by 600 to the power 4. Okay? So, let's just use our calculator. By the way, unit list to this is actually slope. Kung mapapansin nyo, itong ang unit dito, matitira is, di ba? Ang unit na matitira sa numerator is kips inch square, di ba? Same din, ang unit na matitira sa denominator is kips inch square din. Kasi inch square din. Okay, so yan, inch square. Okay, so cancel out yan kasi unitless yan. Radian kasi yung angle natin. Okay? So, ano yung angle natin? Negative 675 times 12 squared divided by 29 times 10 to the 3 times 600. Yan. So, yan. So, negative 0.005586. Yan lang siguro. Okay, radians. So, yan yung slope natin sa B. Okay? So, let's try to solve yung slope sa C. Again, burahin ko na lang to ha. So, I think okay na kayo sa explanation ko sa slope sa B. So, paano ba ito? Burahin ko na lang lahat. Yan, ganito lang, sorry. So, same pa din, ganyan, and then we have, ito yung tangent natin, no? I mean, yung elastic curve natin. Okay? Now, this time, guys, I am interested sa slope sa C. So, to get the slope sa C, same pa din, I'll try to draw, ito, a tangent sa C. So, siguro, pag ganun. Eps, sakto lang. Okay, and then, to solve for the slope sa C, so, kailangan ko lang to. Okay, ito, this is actually the slope at C. Same pa din, I cannot solve for the slope at C directly. Okay, but using the theorem kanina na the change in slope daw between 2 points, I can actually solve sa slope sa C. Now, paano? Okay, now again, same pa din, consider the slope at A kasi nga alam mo kasi yung slope sa A which is 0 horizontal. So, meron kang straight line dyan as a tangent sa A. Yan. Okay, now na-notice mo na this is the tangent at C. This is the tangent at A, di ba? Na-notice mo na the change in slope between the tangent at C to A, yan, ito. Ang change of slope na to, okay, so tawagin natin to. Ganyan. And that is just equal to the slope at C itself. Okay, therefore, the change in slope, ito. So, itong change in slope from C to A is actually equal to the slope at C. Okay, and then, yun nga, alam mo yan, paano isosolve yan. That is just the area from C to A. Okay, yun lang, area ng diagram natin. So, I think ito mas madali, di ba? Kasi, from our figure, ito yung C, di ba? The area is simply equal to the area of the whole triangle, 1/2 base times height. So, 1/2, lagay ka na dito. Sorry. Ang hirap. Yan. Slope at C, no? So, that is actually 1/2, ang base natin is 30, di ba? Yung base natin is yung length ng beam, 30 feet. And then yung height natin is actually negative 60 from our figure, no? Negative 60. So, negative 60. And then, of course, divide natin yan by EI. So, ano yung sagot natin, guys? So, 1/2 base. So, 0.5. Base natin is 30. It's 15 multiplied by negative 60. Okay, so negative 900. So, negative 900. Again, keep feet squared to, di ba? Keep feet squared over EI. Okay? Now, let's try to solve for the exact value nito. So, just say pa din, negative 900. Keep feet squared. And then, let's try to multiply this by, ano yun? 12 squared, di ba? Okay? Divide that by, para ma-cancel out, ang matira na lang is 12 inch. And then, divide that by EI. Ano nga ulit yung E? 29 times 10 to the 3 kilopounds per square inch. And then, multiplied by 600 inch to the power 4. Okay? So, we have our value para sa slope sa C. So, check down natin dito. That's negative 900 multiplied by 12 squared over, ano yan, 29 times 10 to the 3 times 600. Okay, so yung sagot natin is negative 0.007448 radians. Okay? So, I hope okay tayo dyan, ha? So, medyo madali lang, no? Actually, guys, madali lang pag slope yung hinahanap at saka, yun nga, mas madali talaga pag cantilever yung beam. Kasi, pag cantilever kasi yung beam, meron ka ng free slope. Meron ka na, alam mo na yung slope sa at one point, di ba? Alam mo na yung slope sa fixed. So, pwedeng yun yung reference point mo. And then, mapapansin mo na the slope at any point dyan is just equal, okay, to the area from that point to the fixed. Okay, I mean, fixed point. Okay, so anyway, ayun nga, I hope na meron kayong natutunan dito sa example problem na to. So, ito medyo madali lang to. Okay, so, ito pala yung figure niyan, parang ganito. Yan, so anyway, ayan o. So, di ba? Tingnan nyo. Ito yung sinasabi ko na, tingnan nyo, yung slope sa B is just equal to the, okay, from the figure. Anyway, ito man yung dinraw ko kanina. Okay, so anyway, mas maganda nga lang to. Okay, so yun nga, I hope na naintindihan nyo yung first example problem. Kasi nga, medyo madali pa lang to. Now, let's try to move on sa next example problem. Yung next example problem, medyo mahirap-hirap na ang kaunti lang, but still, same pa rin yung process. Okay, let's check down. Okay guys, so let's check yung next problem natin. So, ito yung next problem natin guys. Same pa din, no? Meron tayong cantilever beam. Now, except, no, kung mapapansin nyo, yung meron tayong dalawang segments sa cantilever beam kasi iba-iba kasi yung cross-section. Tingnan nyo, yung cross-section from A to B, medyo malaki, no? Compared sa B to C. In fact, AB is actually twice, no? Sa BC. Okay, yung moment of inertia niya. So anyway, how can we, paano natin isosolve to? So, same pa din guys, we just need to create the moment diagram, yung M over EI. Okay? So anyway, check natin yung tanong. Determine the deflection at point B and C of the beam shown. So in this case guys, yung tinanong deflection na. So kanina, di ba slope yung tinanong. So ginamit natin Theorem 1. So dito, ang tinanong dito sa number 2 is deflection na. So sa kanina no, slope pala yung tinanong. So Theorem 1. Dito, sa next problem natin, deflection na yung tinanong. So we'll be using Theorem 2, yung merong deviations. Okay? So, same pa din, values of moment of inertia, nandyan. Okay? So, paano to? Transfer ko muna. Yan, transfer ko muna yung beam natin. Sandali. Ilipat ko muna sa gitna. Yan. Okay? So, meron tayong moment load dito, no? Na 500 Newton meter. Okay? And then, yung length natin is 4 and 3, 4M and 3M. Okay, so ito, we have ang IAB is equal to 8 times 10 to the 6. Ano yan? MM4. Okay, and then we have IBC na 4 times 10 to the 6. Okay, so let's try, first muna, wag mo nyo muna pakialaman yung I, okay, yung mga moment of inertias. Let's try to solve muna yung moment diagram talaga sa beam. Okay, so ang moment diagram sa beam, solve muna natin yung shear. Okay, yung shear diagram. So, solve natin yung reaction. So, summation of forces vertical, obviously, yung vertical reaction dito is equal to, yung RV dyan is equal to 0. Wala kasing vertical load. So, ang meron lang is moment. So, dapat meron din itong moment. So, ang moment dito is, obviously, no, that will actually counteract yung 500 Newton meter. So, ganyan yung rotation niya. So, anyway, positive yung bending natin, ha? So, positive yung moment natin kasi positive yung bending. Those moment will create, parang ganito yung bending, oh. Parang ismile yung beam. Okay, so, positive. Anyway, dapat equal lang dito, 500 Newton meter. Yan, summation of moment ka lang. Okay? So, I think yan lang. And then, yung shear diagram, obviously, wala tayong shear diagram. But, diretso tayo sa moment diagram. Okay? So, yung moment diagram niya is ganito lang. Positive moment, so 500. Okay? Yan, 500. Newton meter. And then, no change in moment, no? So, constant. And then, dito, we have a bababa, no? Yan. Bababa. Okay? So, I mean, bababa, hindi baba. Equal lang, 500. 500 Newton meter din dito. Yan. Okay? So, yan lang. Now, actually, sa moment, dito sa moment area method, guys, yung moment diagram natin, yes, yan yung moment diagram sa beam, but we are not interested sa moment diagram. No, yes, we are interested, but dito, we are interested sa M over EI. No, specifically, no, M over EI diagram. So, we need actually to divide this by EI. So, notice, guys, ha, sa segments dito, so, i-separate ko to, ha, kasi later on, malalaman, we cannot actually add yung areas na to. And then, papakita ko, dito kasi yung, ito, this is actually M over E, I, BC. Bakit? Kasi, from here to here, that is actually IBC, di ba? Yung moment of inertia na is 4 times 10 to the 6. Likewise, dito, this is actually 500 E, I, AB. Now, hindi pwedeng ganyan yung mga moment. Hindi pwedeng ganyan yung values nyo. Bakit? You cannot add. Hindi mo pwedeng i-add yung dalawang values na yan. Ang area dito at saka area nito, okay, yung area nito, you cannot add. Okay, hindi mo pwedeng i-add yung dalawang yan kasi hindi sila same. Parang you cannot add A plus B is equal to A plus B pa rin. So, pwede mo lang i-add A plus A is equal to 2A. Parang ganun. Okay, so dapat same sila ng variable. So, kailangan mong pumili. Okay, so kung ano yung ano yung variable na gagamitin mo for your moment area. Kung IAB ba or IBC. No, ano ibig sabihin nun? Bali, papalitan lang natin ba? We will just express IAB in terms of IBC or yung yung IBC in terms of IAB. So, ano yung ibig mong sabihin sir? Parang ganito. For example, I will try to express IBC in terms of IAB. So, ratio and proportion lang, no? IBC over IAB is equal to, ano yung value ng IBC natin? That's 4 times 10 to the 6. Divide by IAB is, ano yung IAB natin? 8 times 10 to the 6. Therefore, IBC, guys, is actually equal to 1/2 IAB. Diba? Agree kayo? IBC is equal to 1/2 IAB. Therefore, pwede ko na itong palitan. Okay? So, instead of EIBC, pwede ko itong gawin na 500 Newton meter over IBC. Ano nga ulit yung IBC? 1/2 IAB. Okay? Diba? Parang ganyan na. So, meaning, ang mangyayari guys, ganito. So, this will now be equal to 1,000 Newton meter over IAB. Okay? So, tingnan nyo, ito at saka ito, same na ang, di ba? Same na ang value. Same na ang variable. So, pwede na natin yang i-add. Now, medyo pangit nga lang kasi although same na yung value, notice na yung graph natin medyo may mali sa graph kasi dapat hindi na yan equal. So, babaguhin ko na lang ha. So, parang ganito na yung graph natin. So, ito, mas maliit na to compare dito sa kabila. Yan, di ba? So, kasi, ito kasi, this is now 1,000 Newton meter over again, IAB ha, IAB. Okay, and then ito, this is now 500 Newton meter over IAB. So, with that, guys, yan, pwede mo nang isolve Okay, pwede na natin itong i-combine. So, pwede na tayong mag-proceed sa next step. Okay, kasi meron na tayong M over EI diagram. Now, kanina sir, bakit hindi ka particular kanina sir sa M over EI diagram? Kasi kanina, automatic kasi yung moment diagram natin is just equal to the M over EI diagram. Kasi yung EI kasi natin is constant for both segments. Diba? Ngayon, hindi kasi yan constant, diba? So, hindi pwedeng ito yung diagram mo. Hindi pwedeng ganyan agad. So, ito na yung bago mong diagram. Yung isa, mas malaki sa isa. Okay? So, sir, paano sir pag hindi ko gusto yung IAB? What if sir, yung IBC yung gusto kong i-retain? Okay? So, pag ang IBC guys, yung gusto mong i-retain, same pa rin yung gagawin natin. Just express IAB in terms of IBC. And then, you can actually notice later na masosolve mo na same pa rin yung diagram but iba nga lang yung value. But still, same pa rin yung sagot. Okay? So, bale, ang mangyayari guys, ganito. Buburahin ko to ha. Buburahin ko to. Let's try to use yung IBC daw. What if yung IBC yung i-retain ko? Now, I will try to express IAB, of course, in terms of IBC. Now, I hope agree naman ata kayo no, na ang IAB is obviously equal to twice IBC from our figure, di ba? IAB is twice IBC. So, therefore, instead of ito yung gagamitin ko, dito ko lang sa baba ilalagay, magiging 500 Newton meter over E. Ano yung IAB? IAB is twice IBC. Therefore, this will now become 250. Magiging 250 Newton meter over E IBC na to. Okay? So, yung kabila 250, yung kabila 500. So, again, so pwede ko nang i-combine but medyo pangit pa rin yung diagram ko kasi hindi dapat yan equal. So, parang ganito na yung EI diagram. Okay? So, ito maliit. Dito medyo malaki na to. Twice. So, this will now be 500 Newton meter over E IBC. And then ito, this will now be equal to 250 Newton meter over E IBC. Now, sir, ano yung gagamitin mo, sir? Yung kanina, yung 1,000, di ba, 1,000 yung kanina nasa right, and then yung nasa left 250, but over IAB nga lang. So, ano yung gagamitin mo, sir, na moment diagram? M over EI diagram. Now, either way, kahit saan doon sa dalawa, same pa din yung sagot mo. You can actually try later, after nito, you can actually pause and then try the other diagram, and you'll notice the same lang yung sagot mo. Anyway, I'll be using this diagram na lang, ito na lang, kasi yan na yung, yan na kasi medyo mahirap na pag nagbura pa tayo. So, this is now 4 meters, no? And then this is 3 meters. Okay? So, balik tayo sa tanong. Ano yung tanong dito? Now, ang tanong guys is, the deflections at point B and C. Okay? So, again, draw ko na naman yung elastic curve. Balik ako dito. So, I'll try to draw the elastic curve guys. I-exage ko na lang ha, para mas maganda tindan. So, meron tayong M dito na load. So, obviously, the deflection, it will deflect upward, no? So, siguro, straight line muna ng konti and then, ganyan na. Exage yan, ha? Exage. Masyadong exage. Okay? So, yan. Halimbawa, yan yung elastic curve natin. So, I'm interested dito. Dito, sa deflection sa point B. Ito yung point B, guys, yan. Yan yung point B. I want the deflection at point B. Now, sa Theorem 2 guys, although alam ko na Theorem 2 yung gagamitin since deflection, walang nabanggit na deflection sa Theorem 2. Ano yung binanggit doon? Deviations. Therefore, I need to solve for the deviation. Ang tanong, ano yung deviation na isosolve ko? Obviously, it will involve point B. Diba? So, sa deviation sa point B, but ano yung tangent? Kasi ang deviation, di ba? Ano yung deviation? Deviation is the vertical deviation kasi ito. So, ang deviation na dito, na interesado tayo, is the distance from the elastic curve, okay, to the tangent. Now, asan yung tangent na i-consider ko? Na pag cantilever beam, guys, always remember, magagamit talaga yung tangent sa fixed point. Bakit? Kasi alam mo na kasi na horizontal ang tangent doon. Dito ba? Okay? Alam mo kasi na horizontal, alam mo kasi na straight line lang to, yan o. Straight line lang yan. Okay, so that is actually the tangent at A. Straight line lang yan. So, sir, ano yung mangyari dyan, sir? Now, ano nga ulit yung deviation, guys? Deviation is the distance, no, from the elastic curve to the point. So, actually, guys, ito, ano yung distance na to? Ano yung distance na yan? That is actually now the deviation of B with respect to the tangent at A. Now, it so happened, guys, na the deviation of B with respect to tangent at A is actually equal to the deflection at B. Diba? Ito yung maganda sa cantilever beam. Kasi diretso na kasi. Unlike sa mga simple beams later on sa example natin, medyo meron pa mga ratio and proportion na mangyayari which is medyo mahirap na. Okay, kaya nga sa mga students ko sa review, sinasabi ko sa kanila na pag cantilever beam, automatic moment area na lang agad yung gagamitin. Okay? In fact, yung double integration sa board exam, bihira lang talaga na nagagamit sa board exam. Yung double integration, yung conjugate beam, depende na sa'yo. So actually, depende yan sa'yo kasi yung moment area at saka yung conjugate beam, more or less same lang kasi talaga sila. So depende lang sa'yo kung asan ka mas magaling ba. Okay? So, kaya sa mga students ko sa review, okay, ang sinasabi ko sa kanila na sa board exam, usually naman talaga mga cantilever beams lang yung malabas. Pag ganito yung lumalabas, automatic, just use area moment method. Napakadali, diretso na. Kasi nga, you know the slope sa A na horizontal. And magagamit mo talaga yan. Diretso na. Now, later on sa next example natin, mapapansin nyo, meron tayong medyo mahirap yung pag simply supported beam. Okay, in solving the deflections using moment area method. Okay, so anyway, let's try to continue. Let's try to continue this problem. Okay, so ano nga ulit yung location ng B? This is actually 4M and then this is now 3M, di ba? So, bale, yung moment diagram natin dito, parang ganito, no? Ganon, and then dito tataas to yan. Yan. So, this is 250 Newton meter over E I. Ano nga ulit yung I? AB or BC? IBC pala. IBC. Likewise, dito din is 500 Newton meter over E IBC. Now, naalala nyo pa yung formula? Ano yung formula sa T, B, the deviation of B with respect to A, which so happens to be equal to the deflection at B? Okay? So, that is just the area from A to B. Okay? But, asa natin i-refer? Di ba meron niyang additional na centroid, location ng centroid? Now, the location of the centroid must be, yung centroid ng area, okay, na location ng centroid ng area must be located, no, from the location kung saan din tayo naghahanap sa tangent. Okay? I mean sa deviation. In this case, I am interested sa deviation at B. So, therefore, this is also XB. Yan. Divided by EI. Okay? So, anong mukha niyan, sir? Anong mangyayari, sir? Sorry. So, bale, ganito lang, guys. Di ba ito yung area from A to B? Asan yung centroid, di ba? Yan, yung area from A to B. Asan yung centroid yan? Obviously, nandito yung Nandito yung centroid. Okay? Now, ano yung distance ng centroid na yan from B? No, ito lang yung, di ba? Ito lang yung distance na yan. This is now X sub B. Yan. So, diretso na, guys. I think pwede na to, no? The area is simply equal to positive man, no? Yung moments natin, tama? So, base times height. Ano yung base niyan? 4M pala to. Base is actually 4M. Ang height is 250, ano yan? 250 Newton meter. Diba? 250 Newton meter. And then, multiply that by X sub B. From our figure, ano yung X sub B? 2 meters. Diba? From our figure, 2 meters. And then, divide that by EI. Now, yung EI na yan, galing yan dito, ha? EI. Now, that EI is actually EI BC. Yan, EI BC. Okay? So, I think pwede na, no? Pwede natin isolve yung deviation or yung deflection. So, check natin dito. Yan. So, 4 times 250. That's actually 1,000, no? Times 2. So, this is 2,000. Tama ba? 25 times 4, that's 100. Okay, so 2,000. 2,000 Newton and then M cube. Tama, no? That is actually M cube. Divided by EI BC. E. Anyway, diretso na natin. Ano yung modulus of elasticity? 200 GPa, so that's 200. Ayaw pa na, dapat alam nyo, consistent dapat yung units. So, diskarte nyo na kung ano yung gagawin niyo kung idiretso nyo ba by millimeter, okay, or gawin nyo muna ang meter and then convert to millimeter. Okay, so ako, siguro, check ko muna dito. So, 200, by the way, GPa is 200 times 10 to the 9. Pascals, ha? GPa is 200 times 10 to the 9. Uy, bakit 3 yan? Times 10 to the 9 Pascal. So, that's Newton per m squared. Okay? And then, I'll multiply that by, ano yung IBC natin from the figure? Ang IBC natin is, ito, 4 times 10 to the 6 mm to the power 4. So, 4 times 10 to the 6 mm to the power 4. So, ang gagawin ko, guys, is, ito na lang, i-convert ko na lang muna to into meter. Yung mm ba, i-convert ko na lang into meter muna. So, bali, ang 1 meter, that is actually 1,000 millimeter, di ba? 1 meter is 1,000 millimeter. 1 meter, tama. 100 cm. Tama. Naku po, nakalimutan ko na. So, to the power 4 lang to, times to the power 4. Okay? So, meaning, ang makukuha ko ditong sagot is, ano to? Tignan nyo, ha? It will cancel out. Ito. Ma-cancel out tong mm4 kasi 4 na tayo, yan. Ma-cancel out yan. So, ang lalabas is, bale, ganito, no? Bale, this is Newton. Bale, ang sagot nito is, ito, Newton m cube, dito, Newton m squared, di ba? So, ma-cancel out, ang matitira na lang is meter. Which is, dapat, yan yung matitira. Kasi, ang sagot dito is deflection man, di ba? Distance, unit distance man. So, makukuha ko dito is yung deflection na. But that is in meters. So, 2,000 divided by, ano yan, 200 times 10 to the 9 times 4 times 10 to the 6 divided by 1,000 to the power 4. Okay? So, that's 1 over 400. So, 2.5 times 10 to the negative 3 ano yan, meters. Okay? So, if ever gusto kong millimeter yung sagot ko, I'll just multiply that by 1,000. Okay? So, times 1,000. So, makukuha ko na yung sagot. So, meaning, the deflection at B, okay, sa point B is actually 2.5 mm. Yan lang, guys. Okay? So, I hope okay tayo, ha? Tingnan nyo kung paano ko kinuha yung deflection. Again, although yung second theorem, although walang sinabi about sa deviation, sa deflection, deviation lang yung second theorem, but nasolve ko pa din yung deflection. Kasi nga, from my drawing, di ba? Nakita ko kasi na, yung deviation pala ng B with respect to the tangent at A is equal to the deflection at B talaga. Okay, now, yun nga, ang pangit dito kasi sa area moment method, you cannot actually solve yung mga slopes, yung mga deflections without the figure. Ikaw dapat yung gagawa ng figure. Tapos dapat tama yung figure na gagawin mo. Dapat alam mo na, ito yung elastic curve, ito yung tangent, ito yung slope, ito yung deviations. Okay? So, yun nga, ang the best way to have ibang para ma-practice kayo dito sa paggawa ng figure is of course to solve as many problems as you can, di ba? And then, yun nga, try nyo na lang siguro humingi sa mga instructors ninyo ng mga sample problems. Anyway, sa mga students ko, binibigyan ko man sila ng mga sample problems. Okay? So, yan lang ata. Now, let's try to solve for the deviation at, let's try to solve for the deflection pala at C. Okay? So, I think okay na tayo dito sa B. By the way guys, yung mga sagot natin tama ha, kasi meron tayong solution manual dito. Check ko kung tama ba yung sagot. Okay, so tama yan, 2.5 mm. Now let's try to move on. Let's try to proceed sa deviation sa deflection sa C. So burahin ko muna to. Burahin natin to. Yan. Sorry. So anyway, same pa din yung gagawin natin guys. Tingnan nyo. Ito. I think tama lang yan. So ito, buburahin ko to ha. I am not interested sa yeah. I am not interested sa point B. This time I am interested sa point C. Okay, now sa point C guys, same pa din. 'Di ba? Ito yung point C. Okay? Same ba din? Ano to? Ano ang distance na to? Okay, ano ang distance na to, guys? That is actually the deviation, okay, of C with respect to the tangent at A. Diba? Which so happens to be the total deflection din sa C. So, ganun lang din yung gagawin natin. So, to solve for TCA, which is equal to the deflection at C, same lang. Kunin mo lang yung area from C to A, and then multiply that by the centroid. Ano yung centroid na kailangan natin, guys? Ang centroid na kailangan natin is from C na. Again, bakit from C, sir? Bakit hindi from A? Kasi yung hinahanap natin na deviation is sa C man. Okay, so i-refer natin yan sa C, and then divide that by EI. Okay, so let's try to proceed. Check natin dito. So, I think pwede na natin, no? Diretso na lang. Ilagay muna natin yung XC. So, dito guys, notice na sa area from A to C, okay? Now, the area from A to C, guys, dalawa yung areas natin, di ba? From A to C. We have ito, at saka yan. So, meaning, dalawa din yung centroids natin. Now, i-refer mo yung lahat ng yan from C. Okay? So, siguro, tawagin ko lang itong area 1. Area 2. So, this will be XC1, XC2. Okay lang? So, ayun, okay tayo dyan, ha? So, I think diretso na lang. Ilalagay ko na lang agad yung sagot dito. So, this will be equal to the area from A to C. So, yung area dyan is, dalawa yung area, no? We have, So, ang area, first area muna. I'll try to consider the first area. We have area 1 na 250 Newton meter multiplied by 4M. Yan yung area 1. And then, ano yung XC1? So, ang XC1, guys, from the figure, that is actually 2 plus 3. Tama, no? 2 plus 3. Okay, again, check nyo yung figure natin. Ano yung value ng XC1? That is actually 2 plus 3 or 5 meters. Okay? So, ilalagay ko na lang dito agad na 5 meters. Okay, and then plus, yung second area, we have, ano yung second area natin? 500 Newton meter multiplied by base. Ano yung base natin? 3 meters, no? So, ito yung second area natin, 500 times 3. And then, asan yung X sub C niya? Okay, asan yun? That is actually 3 divided by 2 kasi rectangle man yan. So, 3 divided by 2, that's 1.5 M. Okay, and then divide that by E, IBC. See? So, dapat kasi constant yan, no? Diba? E, IBC. So, actually, guys, pwede man na, iba-iba yung I ninyo na gagamitin. But still, I think mas madali, guys, pag from sa area pa lang, dito pa lang, sa diagram nyo pa lang, tama, i-convert na lang into the same variable ba. Actually, you can still solve this na iba-iba yung variable, but medyo mahirapan ka talaga. Okay, mahirapan ka talaga. Mahirap na. So, mas madali na dito pa lang sa area, consistent na yung mga variables ninyo. Diyan pa lang sa moment diagrams, consistent na. Okay? So, anyway, I think pwede natin i-solve, no? Yung sagot natin dito. So, 250, check na natin. 250 times 4 times 5 plus 500 times 3 times 1.5. Tama, no? So, 7,250. Okay? So, this is equal to 7,250 Newton times M cube over E, I, B, C. Okay? Check it out. Yep. So, okay lang. So, tama lang. So, dapat 9 mm yung sagot natin dito. So, anyway, I'll try to simplify this. So, 7,250 Newton M cube divide by E, which is 200 GPa. 200 times 10 to the 9 Newton per M squared. And then multiplied by IBC. Ano yung IBC natin? 4 times 10 to the 6. 10 to the 6 mm to the power 4. But, gaya nga na pinakita ko sa inyo kanina, we need to multiply this by 1 over 1,000 para makancel out yung mm to the power 4 to, para makancel out yung mm4 at ang matitira is m to the power 4 na lang. Okay? And then, yun nga, makukuha natin yung sagot is in meters. So, check na natin. So 7 to 50, tama ba to? 7 to 50 divided by 200 times 10 to the 9. And then times 4 times 10 to the 6 divided by 1000 to the power 4. Okay, so that is actually 9.06. So tama lang. So 9.0606 times 10 to the negative 3, but that is in meters. So in mm, ang sagot natin pala is 9.06 mm. Okay, so same lang yung sagot natin. Okay, so yan lang. Medyo madali lang, no? Actually guys, medyo madali lang yung pagkuha natin sa deflection. You can actually check yung mga deflections natin using double integration method. Okay, so anyway, sa mga students ko, later on sa quiz natin, you can use any method kung ano yung method na gusto ninyo. But, meron din mga problems, of course, to check if natuto ba talaga kayo sa specific method. Meron kayong mga problems na you can only solve using the specific methods. For example, find the deviation. You can only solve the deviation using sa area moment method. Of course, kung meron kayong alam na ibang method, huwag nyo muna gamitin kasi ito man lang yung tinuro ko, no, to solve for the deviation. For example, ang tanong ko, find the deviation of point B with respect to the tangent at A. So you'll be using area moment. So pag tinanong ko kayo, find the equation of the elastic curve, you'll be using double integration. Okay? So anyway, yan lang ata. Now, let's try to solve. Now, ito sir, ito guys, medyo madali lang to kasi cantilever yung beam. Para bang walang challenge to kasi cantilever yung beam. Pag cantilever kasi yung beam, itong area moment method parang naging 10 times easy yung area moment method pag cantilever ang beam. Now, let's try to solve some example problems na hindi cantilever ang beam. Let's try to solve na mga simply supported or overhang. Okay, so let's try to check yung next example natin. Okay, so next example kasi natin, simply supported na yung beam. Okay, so let's check. Okay guys, so let's try to check yung next problem natin. Yan. So this time guys, determine the slope. So slope to, so theorem 1. Slope at point C of the beam if the modulus of elasticity is 200 GPa, so still, and then we have the moment of inertia is 6 times 10 to the 6. Now in this case guys, tingnan nyo, we are interested sa slope at point C, but we now have a simply supported beam. So hindi na gagana yung kanina, okay, na yung sa fixed point 0 ang slope. So hindi na yun gagana dito sa simply supported beam. Okay, now let's try to solve. Paano natin isosolve yung slope sa C? Now, ipapakita ko sa inyo guys, meron tayong two methods guys to check on how to solve for the slope at C, and then papakita ko sa inyo na same pa din yung sagot. Now, depende lang sa inyo kung ano yung gagamitin niyo. Okay, so anyway, lipat ko muna to dito. So, bali, ganito yun, no? Ito yung beam natin, and then meron tayong load P dito, which is 20 kilonewton. Yan, yan, and then we have yung reactions natin dyan. Obviously, this is 10 kilonewton kasi nga symmetrical naman yung beam, no? 10 kilonewton. Okay? Yung length nito, this is 3m, and then this is 6 meters. Now, I'll try to draw the yung elastic curve muna. So, draw ko yung elastic curve, yan. Sa iba na lang siguro para para medyo madali lang. Okay, so anyway, dito ko ilalagay lang muna yung drawing natin para mas malaki. Yan, so ito yung elastic curve ko. Yan lang siguro. Yan, okay. Now, again, I am interested dito, no, sa, halimbawa, ito yung kalahati. Dito, sa slope nito. So, to solve for the slope at C, I'll try to draw muna yung tangent sa C. So, siguro, pak, yan. Okay, yan yung, wow, tangent sa C. Yan, tangent sa C. Okay, now, to solve for the slope sa C, I think you will agree, no, na ito yung hinahanap ko. I'll try to draw a horizontal line sa C. So, ito yung hinahanap ko. Yan yung hinahanap kong slope sa C. But unfortunately, I cannot solve that easily. Okay, so, ang gagawin ko guys is ganito. Okay, again, sinabi ko sa inyo na kailangan natin ng, meron ako ipapakita na two methods. Now, ito yung first method na ituturo ko. Okay, now, same pa din, yung first theorem natin, we need 2 points, okay? Now, kung cantilever beam pa to, we will consider the point at the fixed support, di ba? Now, since hindi, I'll just try to consider a point dito lang sa support, ito. I'll try to consider this point. Okay? If I'll try to consider that point, so, meron akong tangent na ilalagay, no? Siguro, pag ganito yung tangent niya. Yan. Okay? Ganyan yung tangent. Siguro, this is hindi to tangent sa C. This is tangent sa B. O, tama, C pala. A, C, and D. So, this is C, no? And then, this is point D. Yan. Anyway, so, ito yung tangent sa A. Okay? Yan yung tangent sa A, guys. So, anyway, extend ko muna to. Extend ko. Try to extend. Uy! Sorry. Sandali. Liitan natin. Yan. Oops. Yan. Extend ko na lang. Kasi kailangan natin yan. Anyway, so ito yung tangent sa A. And then we have the tangent at C. Yan. Now, notice guys na to solve for this, I am interested no sa slope sa C. So, I will try to draw a straight line dito sa intersection ng dalawa. So, if I'll try to draw an intersection, now, itong straight line na to, hindi to tangent straight line lang. Gusto ko lang gumawa ng straight line dyan. Yan. Straight line sa C. Okay? I mean, hindi yan sa C, sa point dyan. Now, would you believe na itong angle na to, this is actually the slope at C? Would you believe? Di ba tama, no? Kasi horizontal and then, di ba? Yan yung tangent sa C. So, itong angle na to, this is actually the slope at C. Di ba? So, yan yung slope sa C. Now, would you believe then na ito, ano to? Ito yung nasa Theorem 1 natin. This is actually the change of slope from C to A. Di ba? Yan yung change of slope, guys, from C to A. Tama, di ba? Kasi yan yung angle between, yan yung angle between the two tangents. Sa tangent sa A and tangent sa C. Now, ang tanong guys, I am interested sa, ito. I am interested dito sa C. Now, from the Theorem 1, I can actually solve the tangent at C with respect to A. But, ang hinahanap ko kasi sir is yung tangent sa C. Now, actually guys, itong whole na to, ito. Itong whole angle na yan, I can actually solve that. Ano yung whole angle na yan? Now, that whole angle na yan guys, that is actually, ito yun, no? Ano to, guys? That is actually the slope at A. Yan, no? That is actually the slope at A. Therefore, I can now create an equation, no? So, I can now create an equation na the slope at A is equal to the slope at C plus the slope or the change of slope from C to A. Okay, di ba? The slope at A is equal to the slope at C plus the change of slope from C to A. Ang tanong, I am interested dito. Can I solve the change of slope from C to A? Yes, from Theorem 1. Now, ang tanong guys, how can I solve for the slope at A? Okay? How can I solve guys for the slope at A? Now, to solve for the slope at A guys, simple lang. Ratio and proportion ka lang. Di ba, ano yung slope? Ano yung slope natin? Rise over run. Ito lang, oh. Ito lang yung angle natin. Ito yan, oh. Ano to? By the way, yan. Ano to, guys? Ano to? This is actually my deviation. Di ba? This is the deviation of, ano to? Anong letter nga to? B pala. This is the deviation of B with respect to the tangent at A. Okay? And then, ano yung length na to? Ay, sorry. Ano to, guys? Yan. That is actually, ano to? Ano yung length ng beam natin? From the figure, no? Ang length ng beam is 12 meters. So, 12 m. Therefore, guys, the slope at A is rise over run lang. That is actually the deviation of B with respect to A divided by 12. Now, sir, di ba sir yung slope sir, that is actually an angle? Bakit nag-ratio and proportion ka lang sir? Bakit hindi? Di ba dapat sir arctan dapat yan? Kasi angle yan, that is the interior angle, no? Tapos opposite yung TBA, ito. Opposite and then adjacent yung 12M. Di ba sir dapat yung angle is arctan. Now actually guys, exact gaya ng sabi ko, exact man yan, di ba? Now, the tangent of very small angles is just equal to, parang Para ma-cancel out na lang yung tangent ba? Okay, parang so, tangent of small angles is equal to the angle itself. Parang ganun. Okay? So, ang mangyayari guys, ito lang. Ano yan? Instead of tangent of, di ba? Ay, sorry. Instead of tangent theta A is equal to TBA over 12. Di ba? Ganyan man yan, di ba? So, actually, pwede natin gawin na the angle itself is equal to the TBA over 12. Ganun na lang. Kasi nga, that is for very small angles. That is actually true for very small angles. Therefore, I can now actually solve the slope at C. Kasi kaya ko nang isolve ang slope sa A. Kaya ko din isolve ang slope sa C. Ang change of slope with respect to C from A. Okay, so anyway, let's try to draw our shear and moment diagram. Yung moment diagram lang pala. Okay, so draw natin yung moment diagram, guys. Okay, so i-draw ko muna, guys, ha, yung moment diagram natin. Anyway, yung shear diagram nito, I think, sandali. Yan, I think obvious man, no? So, ang shear diagram parang, sorry. Sorry. So, ang shear diagram is going up, 10 kilonewton, and then constant, kasi nga, walang change of load, and then going down, 20, so this is now, -10, and then constant, and then balik taas, so 0. So, after nyan, so, meaning, may, yung moment diagram ko is, start ako dito, 0, and then increase, linear, diba? Okay? So, ano yung increase niyan? That is actually equal to the area dito. So, 10 times 6. So, 10 times 6, that is actually 60 kilonewton meter. So, 60 kilonewton meter. And then, pababa ito. Balik sa 0. Okay? So, check na natin. Yan. So, I think okay lang, no? So, 60 kilonewton meter. Anyway, I need to solve for the, first guys, I need to solve for the tangent, you know? Ito yung A. Ito yung B. So, ang dami kong isosolve, no? Just to solve for C. So, first guys, I need to solve for the deviation of B with respect to A. So, the deviation of B with respect to A, itong TBA. TBA is equal to, ano yung TBA natin? Area. Diba? Area, area from A to B. But, yung X natin is actually with respect to B over EI. Yan, di ba? Bakit? Kasi I am interested sa tangent at, deviation at B. So, dapat to B yan. So, paano ba to? Obvious na ito yung centroid is nandito. So, yung XB natin is, ito lang. Kalahati, ito lang yung XB. So, I think, pwede na, no? Anyway, check down natin yung C to A. Ano yung C to A? That's just the area from C to A, no? Asan yung C natin dito? Dito yung C. Okay, so ito yung point C. So, the area from C to A, ito yun. Ito yung area from C to A. Yan. Yan. Ito kasi yung A. Sandali. Burahin ko muna. Para diretso na lang, guys. Tapos, check natin. So, anyway, lalagay ko na dito C. So, ilagay ko na lang. I think pwede na to. Pwede natin i-solve agad. So, ano yung general equation natin dito? Tanggalin ko muna, ha? So, yung general equation natin is the slope at A is equal to the slope at C plus the change of slope from C to A. Okay? And then, nalaman natin no, na from our figure that the slope at A is simply equal to T BA over 12. Okay? Tapos, that must be equal to the slope at C plus the change of slope from C to A. So, therefore, guys, the slope at C, okay, the slope at C is equal to TBA over 12 minus the change of slope from C to A. Okay? So, ilalagay natin dito the slope at C, ang taas, no? So, TBA, guys, so 1 over 12. Okay? And then, multiplied by, so, ano yung TBA natin? Area from A to B. Ano yung area from A to B? From our figure, the area from A to B is 1/2 base times height. Okay? So, 1/2, lalagay ko na lang dito. 0.5. Ano yung base? Ang base is yung total length ng beam, which is 12 meters. So, 1/2 base, 12 meters. Ang height is yung 60 kilonewton meter. So, 60. Lalagay ko to dito, 60. Okay. So, tama na, 1/2 base times height. Tama? And then, huwag kalimutan yung x sub b. So, area pa yan. So, yung x sub b is the distance from the centroid of our area. So, yung centroid ng area is obviously yan dyan. So, xb is equal to 3 lang. Equal to 3. So, yan lang. And then, divide that by 12. Okay, and then minus. So, ito no, i-minus natin sa area. Ano yung slope? Ano yung change of slope from C to A? That is just the area from C to A din. Okay? So, to solve for the area from C to A, kailangan ko lang to guys. Oh, ito. Kailangan ko lang to. Ito. Ang tanong, ano yan? Ano yung area na yan? Okay, so ang area na yan guys, kailangan ko ang intensity nito. Ito. Kailangan ko ang height nito. So, do you agree guys na this is actually 30 kilonewton meter? Yan. Ito. Okay? Kasi kalahati lang kasi. Di ba? 3. So, if this is 60, ang height nito 60, that is actually 30 kilonewton meter. Okay? So, balik ako dito guys. So, minus, asan ito? Minus, ang area niyan, this is actually 1/2. Ano yung base from A to C? Ang base niya is 3. Ang height is just equal to 30. Therefore, I can now solve for the slope at C. Okay, so i-solve ko yung slope sa C guys. Check down natin dito. 1/2 1/12 pala, 1/12 times ano yan, 0.5 times 12 times 60 times 3/12, and then minus 0.5 times 3 times 30. Tama ba? Tama. Lagay ko na lang 1. Tama no? 1/12, 0.5, 12, 60 times 3, 12. Okay, so ano yung sagot natin dito? Yan, that's negative 37.5. Uy, medyo may mali tayo guys. Check na natin ulit yung equation natin ulit. So that is 1/12. Okay, so TBA, again, area, that's 1/2. So 0.5 times base is 12. Ang height, 60. Ang XB, guys, mali pala, no? Kaya pala. So, ang XB, instead of 3, hindi pala yan dapat 3. Sandali, burahin natin. Hindi yan dapat 3. Dapat 6 meters yung X sub B natin. So, that is actually 6. Okay, and itong 12, hindi na dapat, wala nang 12 dapat yan dyan. Kasi nasa labas na yung 12. So, lagay ko na lang ang 1. Okay, kaya pala mali yung sagot natin. Anyway, check na natin ulit. So, that is 1/12 times 0.5 times 6. Yan, over, 1 na lang. And then, minus 0.5 times 3 times 30. So, I think okay na to. Yan, that is actually 135. Yan, 135 na lang. 135 over EI. Okay? Now, ito yung sagot natin para sa slope sa C using this method. Yung, ito ba? From our figure. So, sorry. So, tingnan nyo, di ba? Medyo mahirap, no? Pag hindi ka nakagawa ng figure, pag hindi mo nagawa yan, then you can actually not solve C. You cannot solve C. Okay, so ito yung medyo pangit nga lang sa area moment method kasi maganda lang to. At least sa experience ko sa board exam, maganda lang to guys pag ang cantilever beam. Pag hindi kasi cantilever beam, medyo mahirap talaga to. Okay? So anyway, proceed lang tayo. So, tuturuan ko kayo sa other method to solve for the slope sa C. Now, ganito yung gagawin natin. Kanina, same pa din actually guys. Ang concept lang talaga nito is to solve for the slope at C, draw ako nito draw ako dito sa kabila ulit. Ayan. Draw ako ulit. Ano nga ulit? Ganun, no? Ayan. To solve for the slope at C, guys, ang ginawa ko kanina is, di ba, nag-solve pa rin tayo ng another point kasi yan, kasi yung nasa Theorem 1. Sa Theorem 1 kasi, we need 2 points. And then from that 2 points, we can actually determine the difference, the change of slope from the 2 points. Now, dito, ang 2 points na kinonsider ko is ito. Okay, at saka ito. Yan. Okay, na ang ginawa ko, sinolve ko muna yung yung slope sa A. Now, how did I solve for the slope sa A? Yun nga, by ratio and proportion. Ito lang, dinivide ko lang ang rise over run. Now, unfortunately, hindi ko alam ang slope sa A, kaya nag-solve pa ako ng slope sa A. Unlike sa kanina, yung sa cantilever beam, alam ko na kasi ang value ng slope at one point, which is yung fix. Now, dito guys, sa beam natin, kanina, ito yung maganda sa beam natin. Now, it so happen na nga, dito lang sa beam gagana to. Sa beam, sa particular beam na to. Bakit? Sa particular beam kasi na to, I think, alam ninyo, may point dyan na alam ninyo kung ano yung slope. Okay, hulaan nyo daw kung ano ang point. Okay, na alam natin kung ano yung slope. Diba? Would you agree na dito sa point na to, dito, sa point D, ito sa point D, that is actually, sa point D, di ba, symmetrical man yung beam natin? Therefore, symmetrical dapat yung deformation. So, would you believe na sa point D, meron tayong maximum deformation dyan? Di ba maximum ang deformation dito sa point D? And ano yung mangyayari guys pag meron tayong maximum deformation? Di ba sinabi ko na to sa double integration? Pag merong maximum deformation, ano yun? Zero ang slope dyan. Di ba? Y prime is equal to 0. So therefore, you can, instead of considering the point A, instead of considering this point, yung point A, let's try to consider now point D. Kasi sa point D, 0 ang slope. So pwede ko na agad gawin to. Ano? Since 0 ang slope dyan. So, this is actually the tangent at C. And this is the tangent at D. So, ito yung point natin na. This is point A. Point D. Point C. And point B. Diba? So, since alam natin guys na symmetrical ang beam, okay, again, alam natin na symmetrical ang beam from the figure, symmetrical ang beam. So, alam din natin na ang maximum deflection dapat nasa gitna. Ganun kasi yun pag symmetrical ang beam. Maximum deflection nasa gitna, di ba? So, simply supported. Simply supported beam, tapos yan yung load, ang maximum deflection nasa gitna. Okay? So, meaning, yung nasa gitna, horizontal. 0 ang slope sa gitna. Therefore, di ba ito lang yun, this is actually equal to the change of slope from D to C. Or from C to D. Ikaw lang bahala, okay lang. From C to D or D to C. And then meaning, that is actually equal din sa slope sa C. Di ba? Yan yung slope sa C, So, actually, mas madali ito. So, paano to? Diretso na lang agad, guys. Okay? So, to solve for the slope at C, just solve for the change of slope from D to C. And that change of slope is just equal to the area of the moment diagram from D to C din. So, check na natin yung moment diagram from D to C. From our figure. Ano yan? Ito yun, Di ba ito yun? So, kunin lang natin ang area dyan. So, to solve for the area, that is just trapezoid, di ba? Base 3, height is 30 and 60. So, ganun lang. Balik tayo dito. Yan. So, 30 or 60 plus 30 divided by 2 multiplied by the base na 3. Ano yung sagot natin dyan? 60 plus 30 divided by 2 tapos base natin is 3. O, diba? 135C over EI. See? Discarding nyo na yan, So, diba dito, napakadali nating na-solve ang slope sa C. Okay, bakit? Kasi nagkuha tayo ng tangent wherein alam na natin ang slope. Kanina kasi, actually, madali lang sana to kung alam na natin agad yung slope sa A. Kaso hindi natin alam yung slope sa A. Kaya medyo natagalan tayo. Okay? So, kaya, naging medyo mas mataas na yung equation natin. Yan na yung equation natin. So, again guys, this is not, ito. You cannot use this all the time, kasi magagamit mo lang yan, guys, pag symmetrical, simply supported, tapos symmetrical yung beam. Okay? You cannot use this, guys. Hindi mo magagamit tong method na to pag hindi symmetrical yung beam. So, mapipilitan ka talaga gamitin to. Yan. Okay? Yung mas mataas. Okay? So, again, diskarte pa din, So, yun nga, guys, maganda yung area moment pag nakagawa ka ng, number 1 is yung diagram, and then number 2 is ito. Yung relationship yan. Yan ng slope, okay, ng deviations, okay, at ng deformation. So, again guys, ang Theorem 1 and Theorem 2, okay, yung mga theorems na yun, hindi talaga natin magagamit yan to solve directly, okay, sa slope at saka sa deflection. Kasi ang Theorem 1 talks about the change of slope. Hindi slope talaga. Change of slope. Likewise, ang Theorem 2 talks about deviation. Hindi deflections. But, if you try to create yung figure natin, yan, pag nag-create ka niyan, you can actually just create relationships, okay, from the change of slope, from the slopes, okay, at saka from the deviations para ma-solve mo yung mga unknowns. Now, in this case, usually, yung unknowns natin, yung mga slopes at points, at certain points, at saka yung mga deflections at certain points. Now, dito na papasok yung next na topic natin, which is, I think, sa next video na lang kasi medyo mahaba-haba na. What if meron tayong complicated na area diagram? Kasi so far, napakadali ng mga diagrams natin. For example, ito. Yan yung diagram natin. Yan, napakadali ng diagram na yan. Yung kanina, mga madadali lang yung area moment diagrams natin. What if complicated na, sir? Like, for example, ganito. For example, ganyan. Meron tayong ganito. Meron tayong ganyang beam. Ganito yung beam natin. Ganyan siguro. Ganyan. Diba? Pag ganyan yung beam natin, ano yung mangyayari, guys? Diba? Ito yung mangyayari. So, ang shear diagram, siguro ang shear diagram nito is ganito. Upward and then bababa. No? And then tataas siguro ulit. Yan. Tataas and then straight. And then bababa ulit. So, ang mangyayari, ang moment diagram natin, siguro ang moment diagram is ganito. Parang ganyan. And then, ganun. Okay? Now, ito, medyo mahirap yan. Kasi hindi mo alam kung asan ang centered. By the way, hindi ito exactly na parabolic. Hindi yan parabolic. Okay? Hindi yan ang centered. Nandyan, hindi. Mahirapan ka. Ito, asan yung centered nito? Hindi ito triangle kasi this is actually curve. Curve yan dyan. Yan. Asan yung centered yan? Okay, so mahirapan ka na. Okay, so anyway, yan yung sa next video natin. Okay, how can we, parang ang next video natin tinatawag itong moment diagram by parts. Okay, kung saan itong method na to, gagamitin natin to pag medyo marami na tayong loadings. Ang mangyayari kasi guys, pag marami na kasi kayong loadings sa beam ninyo, pangit na talaga yung moment diagrams ninyo. Okay, so instead of using the conventional way to create the moment diagrams, we'll be using moment diagram by parts, which is yan yung next video natin. Okay? So anyway, see you sa next video natin para sa moment diagram by parts. I hope sa examples 1, 2, 3, meron kayong natutunan, no? At least na-imagine niyo kung ano yung paano natin i-solve yung mga deflections and deformations using those two theorems. Okay? And then yung next video natin sa moment diagram by parts, we will deal with complicated, yung mga mas marami ng loads, yung mga beams. And then yun nga, mas ang gagawin natin is iiwasan natin to. Yan, yung mga complicated areas. Kasi as much as possible guys, yung areas ng moment diagram natin, dapat alam natin kung saan yung centroids. And then dito na papasok yung area moment by parts or moment diagram by parts. Okay? So maraming salamat sa panonood, and of course, yung see you sa next video natin para sa moment diagram by parts. Okay? So don't forget guys to like and subscribe if ever nakatulong din ako sa online classes ninyo. Okay? So yan lang muna. Maraming salamat.